students presenting their posters. So we start with Matt Oaks. Matt, it's yours.
Hello. Should I start?
Yep, we should see.
Sure. So what my project basically is, as you can see here, is all about operational technology intrusion detection. And I'm going to be using machine learning classifier algorithms to ideally classify between benign and malicious data. So the reason I chose this project is when I was on placement, I got to experience a lot of time with operational technology and IT, and it kind of opened my eyes to how OT is so far behind in terms of cybersecurity and as in behind the curve. So that was the area I wanted to focus on, especially as well because IT and OT, the convergence between the two is becoming more and more relevant, especially in factories and substations, prisons, water treatment plants, places like that that use a variety of IT and OT in tandem. So these can be susceptible to malicious threats. So therefore, the overall aim of this paper is to assess how and if machine learning tools can be applied for intrusion detection within an operational technology environment. Specifically going to be using the tool Orange Data Mining for that question. So I identified some key objectives, which I'll try to keep to along this project. So the first one was to collect the data and pre-process it. The data set I chose was the CIC Modbus 2023 data set. I got that from the University of New Brunswick. Once I got that, I had to use their tool to pre-process it and get it ready for data experimentation. I then had to select the 5 algorithms that I was going to be using, the 6 algorithms, sorry, that I'm going to be using. And these are naive Bayes, random forest, KNNs, which is K nearest neighbor, SVM, which is support vector machine, decision trees, and neural networks, which are a multi-layer perceptron algorithm. Once I've run those tests, I had to analyze the findings, which were based on the criteria, which I'll show in a minute. And then once I've done that, I had to discuss and review my findings. This image here, this is an overview of the dataset itself, which was simulated for an OT network using Docker containers. So there's a collection of SCADAs, HMIs, and IEDs, which is intelligent electronic devices. So yeah, there's a literature review here, but I'm not going to go into that right now. But if you want to have a read of that later, then feel free. So yeah, next, I just want to quickly go over some of the key methods that we use. So as you can see here again, once I have the data set, I have to pre-process it, test the different classifiers, and then output the results and rank each algorithm from strongest to weakest, and then document my findings. So again, you can see here the different algorithms that we used. Within Orange as well, I had to use I didn't just use one sampling technique, I used 3 different ones and then took an average of the results. So I used 5-fold validation, 10-fold validation, and 66% random sampling. This was so I had more accurate results and wasn't just relying on one simple sampling technique. Because I've used 5-fold and 10-fold validation, so I've used fold validation twice, it's because the data itself is small, itself is on the smaller side, so it is more suitable for that data set. This image here in the bottom left, this is a overview of the entire diagram. So you can see all the different, I'll be able to zoom in on that a bit more. Yeah, so you can see all the different algorithms that we employed here. And so Orange works for almost like a flowchart structure. So you can see here, I can import my pre-processed CSV data set. I can then use this widget here to select the columns. And then all the different algorithms feed through into this widget here, which then outputs the results. I was then able to use the feature statistics widget to identify the 15 most useful features that were then later used to refine the data set for more testing. So for the first round of testing, I used the entire pre-processed data set. And then the second one, I used the top 15, so it was processed even more. And for the final round of testing, I used just simply the top 10. And different algorithms at this point had different results based on these, which the amount of features that we used. Okay. So then going up, the way they were tested and ranked was 4 different criteria were selected, which were accuracy, precision, AUC, area under ROC curve, and F score. These were weighted at 25% each to give an overall score, which was then used to rank them. So if we have a look at the results here, each one of these was weighted at 25%. So we can see the random forest, 93.6, 94.2 for precision, 0.992 for AUC, and 0.942, sorry, for F1. Then these was worked out on an average of each of these and then ranked from strongest to weakest. So, as you can see here, the strongest performing algorithm was neural network, then random forest, then tree, then naive Bayes, then KNN, and then SVM. So that was at this point of the results of the creation of this poster. This was the current working. Since then, additional rounds of testing has been conducted because this was just the first round of it. So the second and third round were conducted later using the 15 and top 10 features. At the bottom right here, you can see all the different references that were used in the making of the poster and the presentation document itself. And these images here of the graphs show the different AUC and accuracy bar charts for each of the different classifier algorithms. So as you can see, random forest, neural network performing slightly lower, tree even lower, and then the final 3 quite high. And similarly for accuracy, they all perform quite differently and they're slightly more consistent at the front end of things. So yeah, that's kind of an overview of my post on my dissertation project. The next steps of where I'm up to now would be at the moment I've got it simply so it's classified between benign and malicious traffic. Ideally, I would like to in future pre-process it more and get them to identify different attack types. So is it a brute force attack? Is it a data injection attack? Is it just surveying? That would be the next kind of steps. So yeah, that's my project, and thanks for listening.
Thank you very much, Matt. Thank you so much. Okay, the next one is Sohail. Sorry, you've got about 8 to 10 minutes, sorry.
Is it sharing the screen? Is it sharing the screen?
Sorry, now I can hear, I can see. Sorry. Do it again. Yes. Oh, yes, we can see you. We can see your poster. Thank you.
We see mine.
Yeah.
So my poster was about the comprehensive analysis of MSPI application within covert operation. Covert operation involved like law enforcement, undercover police, all covert surveillance, obviously people around who work with covert operations. So the introduction of my project is obviously how mobile forensic has drastically changed how organization function of communication today as well. So like communication has been, there's a lot of users now, 5 billion users being used in mobile devices in obviously daily lives during 2019. It's obviously the growth has been increasing since then. And obviously we want to see how MSPI could be input inside of law enforcement and how they use local spyware like MSPI within legal restrictions like regulation of RIPA. Obviously they should be careful of balancing right of privacy to guarantee public safety, obviously while maintaining private information of obviously the person who they're investigating. Obviously, MSPI is very useful to fight any terrorist attacks, obviously drug dealing, murder, or any other like criminal attacks, which are very, very important for how MSPI is like pointing to the system. First of all, I'll start for my aims, objective and research questions. So my main aim of the whole project is to better understand the mobile forensic tools performance in analysis of MSPI application. So how will MSPI differ, and what's the comparison between them? MSPI, and why would they give you more results? Would they give similar results? Would they give different results? And the objectives are to reach these aims would be evaluate the performance of forensic tools regarding data extraction, MSPI application. Second one, evaluation of forensic tools in analysis of MSPI application. Third point is comprehensive analysis of MSPI application regarding to be used by law enforcement. So obviously we will compare the forensic tools once the investigation of MSPI has been done, which has been done at this point of the experiment. The second point will be comparing the MSPI with different tools which I have done here with one of the tools called Oxygen, which I'll show later on in the results section. But to further validate that, I will compare it with another tool called Celebrite and Magna, which would also validate my results which I've gained from MSPI and see, okay, this has given more results, we have different results. So my methodology is the overview of the experiment. So a targeted form was given, specified by the participant for testing reason in a scenario-based experiment. This must be done in a controlled test environment by using multi-VMs, just because I don't want data being cross-contaminated. And also, if anything goes wrong with one of the VMs, there's also a backup of a VM machine to be used for the spyware application. So there's always a backup around. And obviously the program would be used to evaluate, to give any exact real-time data without also the user knowing. So the major advantage of MSPI is that it's very stealthy, so it runs in the background without the person's knowledge. So once it's installed on the target's phone, there's no notification or anything coming through to the mobile device saying, oh, you're being targeted, you're being monitored, your WhatsApp, someone's leaking your messages online, we could see your message, nothing like that. So there's no notification to the phone. And that's very, very useful for like, if law enforcement or court operators or undercover police want to investigate people who've done criminal activities or anything related to what they want to surveil. So these are my methodology to design. So this is how I started it. This installation phase, which I've talked about, that has been very stealthy around the background of the user that they're targeting, and just going around with the first stage, installation phase, second stage, collecting the data. So seeing what data collects, like call logs, GPS location, geolocation, messages within social media, and what kind of what would this information give? So it will provide like geolocation real time. So if a crime happened, before a crime happens, the person knows exactly where the person is. Obviously, they will need like if there was a case in Canada where 10 investigations were done within spy application, where they had to do a remote desktop. Obviously, they have to take RIPA and Regulation of Power Act into an account and other spy laws and laws to do it. So if you have concrete evidence and you go to the court and say, okay, we want to do this, we've got multiple accounts of evidence that this person has done something before and he is leading up to something what we believe that could obviously be in danger to this person, then the court would most likely agree and say, okay, yes, we want to do this, we want to do the application, but you have to make sure that you have ethical and legal stuff into account, so you can't look at anything related to work, you only look into the stuff which is malicious or identifying a crime. So obviously when the third stage after data collection is transmitting of data phase, what obviously designing what the transmitted data gives, so what the collected data gives or what's transmitted, and obviously it'll end there. And then methods to design is what I mentioned here. And obviously my literature review is what the challenges of what I face throughout, might be faced throughout my project, which I won't go through as much. And these are the results. So these results which I mentioned before, the real-time information such as text messages, phones, conversation, images, but obviously there was issues aroused with WhatsApp, Instagram and Snapchat not providing real time. So we would relate to that after P1, problem 2. So I did a comparison between Oxygen and MSpy and seeing like they revealed like different amounts. So social media platform Instagram Oxygen collected 12 and MSpy only delivered 6 logs. So this meaning like MSpy had an issue with the messages not going through at the right time. We'll refer to that after I mentioned about the results. And then obviously we've excelled the area of comparing these results with Oxygen. And I'll also, once this is complete, I'll further go along with comparing it with Celebrite and IEF. So yeah, mentioning these were the problems that was faced during the experiment. It was real-time geolocation was worked properly because of network problem, and the solution was changing the JavaScript itself. But obviously it was a doable with administration rights. And the problem 2 was any potential like hazards or spyware apps that are executed on the computer, which in this case was MSpy, it will be successfully blocked by the network firewall. To solve this, so I did the solution for this. And another solution for that problem 1 was by creating a private network connection inside the virtual machine, which also would help us create a network between only the spyware and the network itself, rather than blocking it from the firewall. And problem 3, the images are not loaded on MSpy server properly, so another solution for this is to fix this in terms of real-time protection on the firewall. And these are the reference mentioned.
I don't think they can see you. It's possible. No.
Can't see.
Just can you see?
No, we can't see you.
Stop it.
Somehow video is gone.
Okay. Stop it. Stop it.
No,
Left.
I can't see.
Because it's on your network. Okay. Suppose
Yeah, the video is working.
technical issues.
Yeah, that was.
Stop sharing. That's true.
And somehow the video gone off.
The video is not working, it's crossed.
It was working before, but suddenly it just went off. That's fine. Let's just continue.
That's weird.
Thank you very much, Suhail.
No problem.
Is it Faisal or is it Sam?
Got a link to it, so it's okay.
Go for it. Go for it. There'll be some next.
Okay.
Downwards.
Nice. It's a bit slow.
Really slow. That was.
That was the second shot.
Sorry?
Enable it. Zoom out. Yeah, share it. Yes, share it.
Why is it not showing the video? Probably because of that ratios.
So this is my project, and it's to do with producing an incident response training game to educate small businesses. So I've done this because from research and like knowledge from small, because I worked at a small business as well. Because of our like technology-driven and interconnected world, the cybersecurity complexities affects basically every business. However, small businesses, they operate with like limited resources, so they don't have like IT teams, they don't have like what large businesses and organisations have. So therefore, they face unique challenges to respond to incidents effectively. So now I'm going to implement a game or like a learning resource, like an interactive one, so that small businesses can start to learn about what they need to do to help them protect their business. So the aims for my project is to enhance incident response knowledge among small businesses and also to promote cybersecurity awareness, again emphasising the role of the incident response. So the objectives of these aims are to develop the game, incident response game. It should also incorporate some educational content. So once they do a part of the game, there'll be like there is some links to like valuable resources so they can start to implement the things that they've learned from the game in their own environment. There should be some like varied incident scenarios. So each episode will be different to like, for example, there could be an IT industry one, so it's more challenging for them. So it's more direct to their business. There'll be like a retail one, so retail employees know what they're doing, that kind of thing. Then I'll integrate some gamification elements, which is part of my project, because that in my literature review, it says that gamification is like one of the best ways to make sure employees are engaged with whatever they're learning. And then I'll refine the game based on user feedback, and then I will disseminate findings and make some recommendations. So here is the flowchart of what I'm actually going to do. So I'll do it. I have done an initial survey which I'll send to small businesses to gather about what they know about incident response, as well as some like game preferences. For example, what kind of things do they like to see in a game? Do they like scores? Do they like decision points? That kind of thing. Then from these responses and the literature review, I started to develop the game and make it like the most interactive it can be in the time frame I've got, and make sure it actually fits their like small business environment. Then I have tested and debugged the game before I sent it out to small businesses to test. I sent a prototype to the businesses. I then ask the business to complete a post-game survey around if their instant response knowledge has increased or stayed the same, to see what's happened because of the game. And I've also done a game experience, so that would be part of the game testing, to see what went well, what went wrong, what I can improve. If it still if everyone says it needs more improvement, it goes back to testing, debugging and making improvements. It goes back to a new survey. It keeps going until it's the best it can possibly be. And then I would compare the incident response knowledge in small businesses from the initial survey right from the start, and then this survey to see how much or how little has it changed in incident response knowledge. The methodology I'm using is a mixed methods approach, obviously, because it's qualitative data and quantitative data, because of I'm doing ratings 1 to 5, doing the game analysis. I'm also asking questions like small-based answers to small businesses about what they like to see, what problems they see in their business about incident response, that kind of thing. I've made the game using RenPy. This is like a development from Python. I've done this because it's like simplicity and flexibility of the framework. And I've learned Python before, so it's the best possible code for me to use. And then a playtesting evaluation, where I mentioned in this flowchart as well, about testing and user feedback, so it helps to refine the game and make sure it's effective and usable. I've done this method because it aligns best to my project objectives, as it allows me for a comprehensive understanding of incident response. Other alternatives, for example, just relying on surveys, may not really show the actual meaning of incident response to small businesses. If I didn't do a game and just see over time if anything happened, there might be nothing. So I need something to help it to see if it actually increases or not with implementation of something, for example, my game. Some early results, my pre-survey results, show that there is some incident response like insecurity. For example, 59% said they were unaware of the term incident response. There was also some little experience with the incident. For example, 27% said they weren't sure if they've had an incident before. 53% said that they've never had an incident, and the rest said they haven't had an incident. The most interesting part of this is that 27%, so about a third, said they weren't sure. This might show that they're unaware of what it actually means, and they need some education to teach them what it actually is. I've developed the game now. I'm starting to do the testing, and a post-game survey is starting to be carried out. And some early results show that there is a slight increase in knowledge after the game. That's my poster so far on my project. Yeah, thank you.
Thank you, Sam. Is it Faisal's turn now? I was able to see Faisal, not anymore.
We're looking in. Can you see this?
Oh, yes, I can see. Thank you.
You see that? Yeah, so my project is similar to Sam's. Can you hear me?
Yes, we can hear you.
Okay, sorry. So my project is similar to Sam's in terms of it is awareness of cyber, but we're looking at the age range of 14 to 16-year-olds. I'm doing an investigation into the abuse of technology amongst teenagers aged 14 to 16. And it is basically looking into the knowledge this age group possess in terms of cyber security and, more importantly, digital forensics and digital footprint. We live in a world where social networking, social media is the backbone of what we do. It's become the norm, and the teenagers nowadays, they use these platforms because they are supposed to provide quote-unquote safe space for teenagers to express themselves, and of course you've got the added advantage of anonymity in there, but unfortunately, with the anonymity, you get a lot of cyberbullying and other disadvantages. And this study was looking in depth at the knowledge teenagers hold around digital footprint and the consequences of cyberbullying, as well as how to stay safe online and how to become more aware of their online presence. So the aims and objectives of this project is to understand the extent of the knowledge teenagers possess in terms of digital footprint, and I'll do this by conducting 2 surveys, one pre-study and one post-study, and create an interactive lesson plan and lesson that will be presented to the participating schools to educate teenagers. And the lesson will cover topics such as digital footprint, online presence, the consequences of cyberbullying, and how to stay safe online, all being tailored to the current social media platforms that are in use, such as Snapchat, TikTok, Twitter, well X now, Facebook, WhatsApp, etc. So my research questions are: what knowledge do teenagers possess regarding digital footprint, and are teenagers aware of the impact of their online presence upon themselves and others? The methodology for this study is quite simple in terms of, at the moment, I've created a pre-study survey, and that was completed by the participating schools today in the morning. I received an email that it's been completed. I'm yet to look at the results because I've been occupied today, but after I've seen the pre-study survey results, which I'm anticipating that they're going to be the negative. So in terms of the questionnaires, if you ask a child, especially between 14 to 16, direct questions such as, do you have knowledge in digital footprint, with multiple answers such as yes and no, the children will probably turn around and just say yes, just to get you off their backs. So the way I've designed the survey is more of a quiz where different scenarios are presented to the students, and based on what they answer would allow me to understand their extent of knowledge in each. So, like I said, the pre-study survey was conducted today, and I've also got the results for that. Next week, next Wednesday, the 27th, I'm going to the participating schools and conducting an hour-long lesson on digital footprint, online presence, and how to stay safe online. This lesson is tailored to teenagers by, like I said before, focusing on current social media trends such as TikTok, X, Snapchat. Also looking at the features of these social media platforms, such as nowadays you've got the Snap Map on Snapchat and Reels on Instagram, etc. Looking in detail at these social media applications, what I've noticed with the key review is unfortunately there's not much work in terms of digital footprint, and when teaching digital footprint, it is taught in such a way where it's kind of vast. It's not tailored to students, and one of the reasons being is because the landscape is constantly changing in terms of what's popular and what's not. TikTok's only got fame in the last few years, so it's hard in itself for schools to catch up with this trend, to be honest. And once I've done the lesson, a post survey will be conducted again, similar to a questionnaire in terms of it'll be a quiz where different scenarios again will be put to students, and depending on their answers will depend on the success of the project. And I've also written up a list of criteria and learning outcomes for the lesson. So there's a lesson plan, the actual lesson, and also an activity which will consist of the use of TikTok and Instagram in lessons. of course, with these ethical issues with this, and one of the biggest barriers I did get was getting into schools, but this is all kind of under wraps because I've promised those schools that are participating that all the information, the names of staff, students and schools, as well as interview responses will be kept anonymous throughout the study.
Doing something now, what's happening?
It's a lunch and learn session.
And documentation.
So, what's the number for downstairs so I can get me back out?
And also, in terms of the Keeley review, I have, this is just a review, but in the actual documentation is quite an in-depth outlook of the current stances that organisations and the government are taking in terms of trying to reduce cyberbullying. The latest being they are trying to, well, the guidance is to impose a ban on the use of mobile phones in schools. According to me and many of the researchers, this only stops the problem, but does not really address the problem. It stops the problem from school hours, but it doesn't address the problem. And arguably, this is even more disturbing and negative because the students are not under any kind of supervision as they would be in schools. And the latest survey from the National Parent Survey in 2023 showed that only 38% were satisfied at the rate with support and resources their school offered for cyberbullying and online cases. So 62 were not satisfied in this. And as I said before, the results just come in today, but speaking to professionals in the area and teachers, it's a known fact. It is a very known fact, as well as the research that the resources in this area are lacking. And I'll end with what one of the staff members said in one of the participating schools, where the participant said, unfortunately, over the years, the strain on the education system has increased, and schools are facing a huge backlog of new and persistent issues. With the cost of the living crisis and the recent pandemic, schools, including ours, are under immense pressure to continue operating, let alone provide an outstanding educational experience. The issue of cyberbullying has been discussed previously, but the bulk of the educational results are outdated and do not address the digital footprint effectively. Interviewer continues by saying digital footprint is only really spoken about within careers lessons, and that too not in much detail. So I hope this has been insightful, and it's a study which needs to be done. So thank you very much.
Thank you so much, Faisal. Thank you so much, Sam, and Matt, and